Cool. Let's go ahead here. Okay, calculating proportions and percentages. This is the last portion of this particular section of content. So we have the same table. We have avoidance in number of days. We have frequency. I'm introducing you all to two additional concepts here. We're calculating proportions and percentages. We start with proportions. A definition for proportions is that it is the measure of the fraction of the total group that is associated with each particular score. So you apply this formula, P equals F divided by N, to each of these individual rows of data. So in order to calculate the proportion, for example, um, well, actually, for any of them, we need this n thing here. If you happen to remember from the end of the first module on what is behavioral statistics, n equals your number of, ooh, this is going to be rough, participants. Number of participants. To calculate the number of participants for a frequency table, you can simply add up all of the numbers in your frequency column. That tells you how many people participated. We happen to know, because we've worked with this data a few times now, our n for this is 30. We had 30 people respond to this question. So, in order to calculate the proportion for any one of these categories, we're going to take the frequency of that category and divide it by n, the total number of participants in our data. Okay, so for this first category here of 8, P is going to equal 3 divided by 30. As a habit, I want y'all to give me two decimals. All right, two decimals when you are presenting numbers to me. If we were doing, if we were doing this math in a more rigid sense, we would maintain at least 4 decimals throughout our entire mathematical process until we got to the final answer to have our best shot, of having the most accurate answer. Okay. That's really important to know. It would be 4 decimals throughout, an entire mathematical equation. And later in the semester, we'll do that as a matter of maintaining that. Or I should say, we may do that. Sometimes it gets a little bit tricky and in some cases unnecessary, just because ultimately we're moving into SPSS anyways. But I do want you to have, a solid understanding of what I'm trying to convey here. So what I mean is, if we take this equation here, 3 divided by 30, we end up with simply 0.1. I want you to give me 2 decimals. So even in the case where you end up with 0.1, I would want you to give me 0.10. That's the final answer of this mathematical process. If we were determining the proportion for this second category of 7 days, we have 3 divided by 30, which we've determined is already 0.10. For this next category, we have, here's a really good example. P equals 2 divided by 30, which the answer is, from my calculator, 0. I'm going to drop the first 0, 0.0666. It's technically 6666 a whole bunch of times and then 7. I'm going to stop at the 4th decimal just to illustrate this point about 4 decimals. If we were doing a much longer mathematical process, we would maintain 4 decimals throughout until we got to the end where we would only round to 2 decimals. This technically here is as far as this mathematical process goes. So even though I'm writing out 4 decimals here, this is to illustrate the rounding process in case some of y'all might be a little bit, rustier on your rounding. When we are rounding, if I'm asking you for 2 decimals, you want to look at what's happening at the second value after the decimal, as well as the third value after the decimal, because a third value is going to indicate to you what you need to do or not do with the second value. A reminder for rounding: if you have, in this case, a third value after the decimal that is 4 or lower, so if it were 4, 3, 2, 1, or 0, you would leave the second decimal as is, whatever that number is. On the other hand, if the third value after the decimal is a number that is 5 or higher, 5, 6, 7, 8, or 9, that is indicating to you that you need to take the value in the second decimal place and move it up 1. Okay, increase its value by 1. So in this case, 0.066 tells us this 6 here. This third 6 is telling us to move this second 6 up to a 7. So your answer for me is going to be, I don't know why that's happening. That's wild. 0.07. All right, that's the answer that you would give me. So we'd also have 0.07 here for this proportion. We have 3 divided by 30, which is 0.1 here. This 4 is new. So if we have 4 divided by 30, that gives us a value of, I'm going to write this one out. Wait, let me write this first. 4 divided by 30, which equals 0.1333. I'm writing out 4 decimals just to illustrate this rounding principle again. We want to know what to do with this second value after the decimal, this 3. And so we're looking at this third value after the decimal, this 3. It is a number that is 4 or lower, which is telling us to leave our second value after the decimal alone. So we have 0.13. That's the answer you would give me. We have 0.13 here. And we'll do 6 divided by 30. P equals 6 divided by 30 equals 0.2. My calculator only gives me 0.2. Give me 2 decimals, 0.20. Okay. And then finally, we have this last category, 3. We've already determined this one a couple times, 0.10. So that is how you calculate the proportions for any one of these categories. I'm going to click the next slide here and then delete. Just to, I had already done the math before, but just to have it for you here. And then now let's take a look at percentages. Percentages measure our proportions out of 100. You've likely seen percentages, throughout a variety of spaces throughout your life. I don't know why my mind is going to sales right now, right? You see a sale that says, get this 20% off, 30% off, 40% off, whatever the case may be. In order to calculate a percentage, you're going to take the proportion, so the proportion that you calculated here, and you're going to multiply that number by 100. A little trick here when working with, from proportions to percentages is that you can take any one of these proportions. So let's say, for example, 0.10 multiplied by 100. And because we're ultimately going to be calculating percentages, you want to make sure you include the percentage symbol. This is also the case when it comes to your learning check. Your learning checks have been constructed in a way that if I'm asking for a percentage, I am looking for you. You need to include a percentage symbol in your answer. If you exclude the percentage symbol, the answer is wrong, right? It sounds kind of petty, but trust me, when you are being asked to present data, present information, and you present inaccurate information, then you're not, for one, you're not being considered as a legitimate social scientist, but for two, you're not accurately reporting on what it is that you're trying to report on, what you're doing this research on. So this trick for working with percentages is that your decimal can be moved when you are multiplying a proportion by 100. You can move your decimal two places to the right and add a percentage symbol, and that is your percentage. So in this case, we have 0.10 multiplied by 100, which is 10%. We could have also done, if you look at this 0.10, you move it one place to the right, two places to the right, include a percentage symbol, is 10%. Okay. If we were to do that here with our, with our 0.7, move our decimal one, two places to the right, and we are going to have 7%. We'll move this 0.13, two decimals to the right. We're going to have 13%. Here with this 20, move it two places to the right, we will have 20%. All right. So we just kind of move forward here. Of course, I already did the math on this one. So moving from proportion to a percentage, you can move your decimal two places to the right, include your percentage symbol, and you're good to go. Okay. So I'm pretty sure that's all we got for this particular video. Let me just double check. Yes, that's the case. Um, so remember, you want to get in the habit of making sure that you understand how to read these tables. If you're reading a frequency table, if you're reading a participant data table, you want to get in the habit of being able to recognize the elements of each of them, because they indicate to you as the audience what it is that, the data that you're consuming. When it comes to you presenting this material as a researcher, you want to keep in mind that how you are presenting the material matters. If you're presenting nominal data, you have to include your categories, you have to include your frequencies. If you are presenting ordinal or interval ratio data, you have to consider, does it make the most sense to have, from the top down my categories, or have from the bottom up in my categories? The rationale that you have as a social scientist is important. So keep that in mind.